right, well, welcome back. And what we're going to talk about is we're going to go through a little brief lesson on 7.1 and this idea of sampling distribution. Sampling distribution. If you are following along with an AP Stats, you probably have just completed binomial and geometric settings and distributions. And we are now jumping into this idea about sampling distribution. And the key things that you probably want to write down, so you probably want to put this in your note, is this thing between a parameter and a statistic. Now, we hear about statistics, and actually, if you're taking AP stats, all right, this value of statistic might be a little bit confusing still, but a stat is really a number that describes a sample. So we are taking samples of a population. And one way I remember that is a stat and a sample both start with S, so statistic and sample are conjoined that way. A parameter right here, okay, is about the population. It's about the population. So P, parameter, population, that is a number to describe a population. So when you have these different ways of describing this, is that we have basically three different values or statistical marks that we use are means, proportions, and standard deviation. And when you have parameters, we talk about this mu, okay, and that's for a parameter. For a stat, when we have from a sample, it's going to be x bar. We call that x bar. Same thing when we have p, that's for a proportion of a parameter of the population, and we have p hat, and we call it a little hat. P hat is talking about the stat, so the proportion of the statistic you found. In the same way, we have standard deviation. All right, we have this delta right here, and then we have little standard deviation S is for a stat, the standard deviation that we found. Now, when you look at for a sampling distribution, it shows all the statistics, all the stats found in all possible samples of size n. So essentially, it's like this binomial distribution. You're taking samples of a population and you're figuring out all the different combinations that could happen. Okay, and the reality is that when you plot all these various combinations, one dot in our sampling distribution stands for the one sample that you made, that you did, or somebody took. The question is, where is this sample located? And that's where this big idea of the sampling distribution and determining what the sampling distribution mean and standard deviation is that this will lead us to understanding that some points, some stats that we find may be more common than others. And so, for example, a statistic over here appears to be more common than a stat that's lying in this area. And so the question is, when you find an uncommon stat, does this maybe offer you pause, as I would say? Does your Spidey, since Spider-Man's coming out, does your Spidey sense come up and saying, maybe something's happening here? And so that's what we're doing. So in the sampling distribution, remember that's all the possible samples, and when you graph these, one dot in the dot plot of all your sampling distribution statistics is just simply one of the samples of a statistic that we have, that whatever you're taking of n size. And then remember, the population distribution shows all individuals. All right, so population distribution is all individuals, and that's what we have there. Okay. So population is all individuals. All right. Sampling distribution is all the statistics for this sample size n. Okay. Usually get population distributions for censuses, and this one is just mainly for basic sampling. All right. So let's try some problem. Let's try a problem here. Let's check your understanding here. And I'm going to just say, I'm going to thank StatsMedic for all this because I'm using their information. So StatsMedic, thank you very much. Give a shout out to Luke and all of them. Or StatsMedic. So if you haven't checked out their website, check them out. They have a lot of great material and also have some great videos as well. So, but in any case, we have check your understanding. Determine how much homework time students will get in class. Mrs. Lynn has a student select an SRS of 20 chips from a large bag. The number of red chips in SRS determines the number of minutes in class students get to work on homework. Mrs. Lynn claims that there are 200 chips in the bag and that 100 of them are red. Okay, so here's a claim. She's going to do an SRS, so this is our sample. All right, the claim, which she is assuming that there is going to have 100 of those are going to be red. When Jenna is selected a random sample of her 20 chips, looking at the bag, she only noticed that there's only 7 red chips. Does this provide convincing evidence? Now, not a question, is inference. Does this provide convincing evidence? All right, that there's less chips in the bag. Okay, well, first off, let's identify the population parameters and whatnot. So, of the population, all right, the population is, all right, the chips, or the red chips, right? All right, so identify the population, and so what we'd have is the number of red chips, okay, or number of red chips. Our sample is number of red chips. Okay, well, I guess the population is 100 chips, or sorry, 200 chips, I apologize. It's like 200 chips. All right, 200 chips, I apologize. All right, and out of this sample, we are only taking 20 chips, okay? So our N value is 20. All right, our N value is 20 chips out of this. Okay, yeah. Our parameter is we are trying to decide how many red chips we have. So of here, we have our red chips, and this one would be a p-value, okay? So our p-value is we would have basically 100 over 200, and so we would have half. 1/2 of the chips would be red. Now our stat, what we found was something different. We found that we had right here, that was going to be 7 out of 20. So we 7 out of 20, which is a little bit less than 1/2. Because if you put this in a calculator, all right, we have 7 divided by 20. It's going to be a little bit less. So that's going to equal, all right, 0.35. Okay, 0.35. Now, from here, what is the evidence that less than half the chips in the rig are red? Well, the reason why we have that is because our stat right here, our p-value right there, our statistic is less than our actual p-value, all right, because we got 0.35, and this was, we had 0.5, okay, 0.5. So that's our rationale. So provide 2 explanations for the evidence described in part A, okay? So what could happen in part A? Well, either A, number one, it could be happen by chance, okay? It could just be simple chance, all right? That we had a less thing, so it could happen by chance. Or 2, there really are, all right, less, okay, red chips in the bag, red chips in bag, and so we are misled, okay? And so the question is, if it's by chance, okay, we had a bad day. We accidentally just chose 7 out of 10 instead of 10 out of 20. All right. Are there less, or there actually could be less chips in the bag? So the question is, how do we figure this out? Well, using technology, we can simulate this. Okay, and this is what you see a lot in doing this. So you're going to simulate. Let's just say we did 500 SRS of a sample size of 20. So from the population of 200 chips, 100 red chips, and 100 blue chips. So dot plot shows that p hat, the sample proportion of red chips for each of the 500 samples. So if you did this repeatedly, and let's just be assumed that the p-value was actually 50%, all right, and we just randomly chose that out of the population, there is a 1 dot on the graph at 0.8, okay, 0.8. Explain what that value represents. Well, what that means is that one sample, all right, of the 500, all right, one sample of the 500, all right, samples of size 20, all right, size 20, had size 20 had what? Well, if we take 20 times, all right, what's 80% of 20? Well, it's going to be 16, right? We had, so when you pick that up, so one sample of the 500 samples, all right, in the distribution, I'm going to put that in the distribution. No, I just keep it even simpler. Sorry. One sample of size 20, right, had 16 red chips chosen. That's what happened. All right, that's what we got. So one sample of size 20 had 16 red chips chosen. That's what happened. And so right here, would it be surprising to get a sample proportion of 0.35? All right, so if you look at our smaller, so if we look at this, our SRS, and when we have sample size, when P, oh, we promised it, when sample size of 20 had red chips chosen, when the assumed, all right, P value, or the proportion was 0.5, because that's also important. Because one sample of size 20 in there, because we want to make sure that we have, we're assuming that this is going to be 0.5 when we chose it, because it could be something else. So we're assuming it's 0.5. And so justify your answer. Well, looking at this, well, where's 0.35? Well, 0.35 is going to be right here. And if you look at all of these values right there, this appears to be very, 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 very common. Okay, very, very common. So if we were to take this right here, okay, what's the probability of giving a sample of less than 0.35, 3.5 or less? Well, it appears to be very common. So would you be surprising? No. All right, because obtaining a p-value of 0.35 or smaller is common. All right, it is common. Right there, it doesn't seem to be very, very, very uncommon. All right, there's many different values of 0.35, and then lower than that, there still is more values, so it's not very common. So no, we wouldn't be surprised by that. So based on a previous answer, is this convincing evidence that less than half of the chips in large bag? It'd be no. All right, no, it is not convincing evidence. All right, because, all right, our then we would say our p-value, actually that's what kind of, the proportion, because proportion, or the number of samples, all right, or because the proportion of the number of samples, because the proportion of the number of samples of 0.35 or smaller is large. Okay, all right, large. Or you could just say no, it's not very common. All right, no, because no, because getting a sample, all right, getting a, all right, p hat of of 3.5 or less, all right, is common. All right, we could also just say that, maybe that'd be easier. All right, so that's what we have there. So once again, all right, sampling distribution. Sampling distribution is taking all the possible samples, all right, and obviously these aren't all the possible samples of what we could do, all right, but is quite a few. But what we have right here is what is our sample proportion of the red chips, and seeing this right here, we had several samples, many samples of 0.35 or less. That's why this is not convincing evidence that we have, all right, that the bag is lying, all right, that we don't have 50% of red chips in there. Okay, so back to what we have right here, real quick. Parameter and statistics, knowing the difference between there, and sampling distribution gives all the possible samples of size n inside there, with a certain parameters or statistics based on the parameters that we are assuming, assumptions. All right, well, hope this helped you out. Good luck and God bless in the rest of your problems.